Okay, I want to start today with a bit of a horror story. And I don't mean, goats or anything like that. I mean a real developer's nightmare.
I think I know which one you're talking about. Is this the Reddit thread from our source material?
That's the one. So just picture this. You're a developer. You're all set to get some work done. You fire up your environment with Claude Code, which is Anthropic's new tool, and you think, okay, let's connect some tools to this.
Yeah.
So you connect 4 MCP servers.
Just four, which, I mean, that's not a lot. That's a pretty standard setup, right? Like your file system, maybe a database, a browser.
A GitHub integration, something like that.
A totally normal stack.
A basic setup. And before you type a single prompt, before you even say, hello, Claude, you check your usage. And you find that 67,000 tokens have.
Yeah.
Well, they've just vanished.
It's painful just to hear that number, 67,000.
It's devastating. That's roughly the size of a small book. Gone. And you haven't even asked the AI to do anything yet.
And that right there is really the core of our deep dive today. We're looking at this sort of invisible problem in AI engineering that people are calling context bloat.
Now, the team behind Claude Code is trying to fix it with this new feature, tool search. Because looking at the reporting in the community chats, this isn't just some technical bug. This is, you could argue, an economic problem for anyone building AI agents.
It really is. I mean, the headline statistic we're going to unpack is a 46.9% reduction in total agent tokens. It changes the math on everything.
It basically cuts your running costs in half. But before we get to the solution, we have to really dig into the problem itself. We have to figure out why our tools were, eating themselves alive.
Right.
So our mission today is to figure out, how did connecting just 4 servers burn through that much data? How does this new tool search thing actually work? And this is where I think the sources get really interesting, we have to look at the criticism.
Oh, the criticism is fascinating.
It is. You have some really smart folks in the community, people like Damian Barazenko and Angu Collins, who are pointing out that this fix might actually, break how AI finds solutions in the first place. They're calling it a chicken-egg problem, and I really want to get into that.
The classic efficiency versus capability trade-off?
Exactly. But first, let's talk about the villain, context bloat. We said 67,000 tokens for 4 servers. To someone new to this, that sounds like a glitch. But this was actually working as designed, wasn't it?
It was, yeah. And to get why, you have to understand the Model Context Protocol, or MCP. It's basically the open standard that lets an AI like Claude talk to your stuff, your files, your database, whatever. It's the bridge.
It's the pipe connecting the brain to the hands.
That's a great analogy. Now, the original design was all about, let's call it radical transparency. When you connect a server, the system grabs the entire definition of every single tool on that server and just shoves it straight into the context window.
And when you say definition, we're not just talking about a list of names, right? Like read file or write file.
Oh, no. We are talking about the full, unabridged instruction manual, the schema. So for a tool like read file, the context doesn't just get those words. It gets the description, reads a file from the local file system. It gets the parameters like path, type string, and so on.
The error states, the JSON constraints.
The whole thing. It's literally formatting all that structural data into text and feeding it to the model so the AI knows exactly how to build the API call.
Okay, so I'm starting to see the math problem. If I have one tool, that's fine. A few hundred tokens, who cares? But the source mentions this multiplier effect.
Right, and that's because nobody uses just one tool. If you connect a GitHub server, that's not one tool. That could be 20 tools. Create issue, get pull requests, list comments.
And then you add your database server.
Another 15 or 20 tools right there.
And a file system, a browser.
And suddenly you're at, say, 167 tools. And if each of those has a pretty detailed 300 token definition.
You're already at 50,000 tokens before you've had your morning coffee.
Precisely. And the real problem isn't just the cost, though that's huge. It's a kind of distraction for the model.
That's a great point. I think a lot of people think of the context window like a hard drive, just storage, but it's not. It's more like an attention span.
Yes, that is the perfect way to put it. If 90% of what the AI is thinking about is just the definitions of tools it isn't even using right now, its ability to reason about your actual problem goes way down. It's like trying to write an essay while someone screams the dictionary at you.
I love that. And it explains why that Reddit user was so upset. It's not just the money they lost. It's that their super powerful AI was so weighed down with baggage, it couldn't even move.
The source said it perfectly. MCP servers got wildly popular, but that popularity just exposed this massive underlying inefficiency. We gave the AI superpowers, but the weight of all those powers kept it on the ground.
So enter tool search, the proposed solution from the Claude Code team. Functionally, this is basically changing the architecture from a push model to a pull model, right?
That is absolutely the best way to think about it. The old way pushed everything in at the start. Tool search implements a pull model.
So walk me through it. From the AI's perspective, what does that feel like? How does it know what it can do if we're not telling it everything up front?
Okay, so imagine the old way. You walk into a library, and the librarian just dumps every single book onto your desk and says, the answer's in there somewhere. Good luck.
That's a nightmare. I'm leaving.
Right. Tool search is the card catalog. Now, when you connect those same 4 servers, the AI doesn't get the full schemas. It just gets an index, a very lightweight list of what's available.
So it just gets the tool names and maybe a quick one-sentence summary, like, I have GitHub tools, I have file editing tools.
Exactly. It's a tiny fraction of the data. Then when you give it a prompt like, hey, can you check the latest PR on the main repo? The model looks at its index, it sees GitHub tools, and then it performs a search.
So it's querying its own system, basically. Show me the details for the GitHub tools.
Correct. It retrieves only the specific tool definitions it needs for that task, for that moment. It loads them into context, uses them, and this part is important. It can dump them later if it moves on to something else.
And the numbers back this up. The report gave us specific before and after. They went from, was it 51,000 tokens?
Down to 8,500.
Wow. That's just staggering. That's not a small improvement. That's a total game changer.
It's an order of magnitude difference. And you mentioned the economics of it all. This is where it gets really serious for anyone building autonomous agents, because a casual user might think, oh, who cares? Tokens are getting cheaper. But we're not talking about a single chat prompt here.
No, we're talking about an agent. An agentic workflow is a loop. The AI thinks, calls a tool, gets a result, thinks again, calls another tool.
You might do that 10, 20, even 50 times to solve one complex bug.
So let's play that out. In the old model, if your setup cost is 50,000 tokens, you're paying for those 50,000 tokens every single time it goes through that loop.
Yes, that's the real killer. The context window is resent with every single inference step. So on a 10-step task, you're not wasting 50,000 tokens once. You're wasting 500,000 tokens.
Okay, wow. That puts that 46.9% reduction headline in a totally different light. It's not about saving a few pennies. It's the difference between a task costing $2 versus 10 cents.
It's the difference between an agent being a cool demo and being a commercially viable product. If you're building a company around AI developers, you simply can't afford that brute force method. You'd burn through your funding in a week.
And there's another piece to this too. Latency. Just the speed of it all.
Oh, it's a huge factor. Yeah. Processing 60,000 tokens takes time, even for the fastest models. If you have to wait 10 or 15 seconds for the model to just read the cool definitions before it even starts thinking, that completely breaks your flow.
Absolutely. If I'm trying to pair program with Claude Code and I have to wait 20 seconds for every single response, I'm just going to Alt-Tab and do it myself. It's faster.
Right. So tool search isn't just about saving money. It's about making the interaction feel snappy. It's about user experience. If an AI feels slow, it feels dumb. By stripping out all that bloat, the AI feels sharper, faster, more responsive.
That's a great point. It's UX design, just disguised as back-end engineering.
Exactly.
So on the surface, this feels like a home run. We've gone from the library on the desk to the card catalog. Costs are down, speed is up.
Time for a victory lap, right?
Well, not so fast, because this is the deep dive, and we always read the comments section.
And the comments on this piece were surprisingly philosophical for a technical update. I love when that happens.
It was great. I want to zero in on a point from a user named Damian Berazenko. He looked at this tool search idea and immediately saw a potential flaw. He called it the chicken and egg problem.
It's a classic information retrieval paradox, really. What he asked was, how do you know if you have a tool to search for before having a list of tools?
Let's unpack that. If the AI doesn't have the full instruction manual loaded, how does it even know it can solve my problem?
Right. Let's use an example. Say you have a really specific niche tool, maybe one that converts an obscure image format, like, I don't know, .heic to JPG.
Okay.
In the old system, the bloated one, the AI sees the tool name, image converter tool, and the full description. It knows immediately, I can do this. The capability is right there in front of it.
But in the new system?
In the new system, it might just see a generic index. Maybe it just says image tools. If that index isn't descriptive enough, or if the AI doesn't make that intuitive leap to search for a conversion tool, it might just come back and say, sorry, I can't help with that.
It introduces uncertainty.
That's the exact word Damien used. You're trading perfect knowledge for efficiency. And that efficiency completely depends on the model being smart enough to guess that a tool it needs might exist behind that search query.
It feels a little like using a search engine in the late 90s. If you didn't know the exact keyword, you were out of luck. Are we kind of doing that to our AIs now?
That is the fear, yeah. If the tool is hidden behind a search, the AI has to infer its existence. And these models are smart, but they're not psychic. If a developer gave a tool a weird internal name like Project X for a database tool, and the AI searches for database, it might miss it entirely.
So we've solved context bloat, but maybe created a discovery problem.
Precisely. And this ties into what another commenter in Collins was saying. They pointed out that they had already built a sort of DIY version of this themselves.
Yeah, that was fascinating. Colin said they just moved away from MCP servers and started using CLI's command line interfaces.
Right. So instead of a server that broadcasts all its tools, they just gave the AI access to a terminal and said, hey, if you need to use AWS, just run the AWS command.
Which is the ultimate form of lazy loading.
It is. But there's a key difference. In that method, the human is usually the one prompting it. The human says, use the AWS CLI for this. They're providing the initial context.
Right, whereas with tool search, we're asking the AI to be the one to figure it all out on its own.
And that's where the discovery problem can really bite you. So, and Collins' comment proves the need for this was their developers were already hacking solutions. But this official tool search feature relies so heavily on the AI's own reasoning to navigate that index successfully.
So if you write a bad index, you end up with a dumb agent.
Basically, yeah. The metadata, the descriptions, they matter more than ever before.
There was one other really practical point from a user named Steve McGee, and this is for anyone trying to actually use this today. He asked about pre-compiled servers.
Ah, the implementation headache. Steve's question was, does this work automatically, or do I have to go add defer loading entries to everything?
And defer loading sounds like it's the little flag you have to set in the code.
It is. It's what tells the system, hey, don't load this one yet. Steve's point is that a lot of people are just downloading pre-built MCP servers. They're like these sealed black boxes.
You can't just crack them open and start editing the code to add that flag.
Exactly. So if that server wasn't built with this new feature in mind, what happens? Does it just break? Does it default back to the old bloated mode?
And it seems like the answer is, it's complicated.
It usually is. It suggests that for this to really work across the whole ecosystem, every single person who builds these tools needs to go back and update their servers to support this new standard.
So we're in this messy transition period. We have the new engine, tool search, but some of the servers are still running on the old fuel.
And until they're all updated, you might find that some of your tools are super efficient and others are still dumping thousands of tokens into your context window because they just don't know how to wait.
It's messy. But I guess that's just the reality of working on the cutting edge.
Always is.
Okay, so let's try to wrap this up. We started with a developer watching their context window just explode.
A tragedy in 67,000 tokens.
We found the culprit.
Yeah.
The old push model that loaded every instruction manual into memory all at once.
The dreaded multiplier effect.
And we looked at the fix, tool search. A poll model that's more like a card catalog, cutting token usage by almost half.
Which saves money, saves time, and frankly makes these agents actually viable as a business.
But we're leaving with a pretty big asterisk.
The discovery asterisk.
And I want to leave you with this final thought, building on what Damien said. We're moving towards a world of autonomous AI agents. The whole idea is that they can go out, find the right tool for the job, and just get it done.
Right. That's the dream.
But if we hide all the tools behind a search bar to save on costs, are we accidentally making our AIs less creative?
That's the question, isn't it? Serendipity is a real thing. Sometimes just seeing a tool you weren't looking for gives you a new idea.
Exactly. If I see a hammer on the workbench, I might think of a new way to use it. But if the hammer is tucked away in a drawer and all I see is a label that says construction tools, I might never make that connection.
We could be trading potential genius for guaranteed efficiency. We're optimizing for the most common path, but we might be closing the door on those weird, unexpected solutions that come from having, too much context.
It's a balance I think every developer building an agent is going to have to think about very carefully. Do you want your AI to be cheap or do you want it to be omniscient? Because for right now, it seems like you might not be able to have both.
A fascinating problem to have in 2026.
It really is. A huge thank you to all the community members whose comments we discussed. N. Tollins, Damien, Steve McGee, and of course, to the reporting that made this deep dive possible.
Always a pleasure to get into the code behind the code.
Thanks for listening. Check your token usage, maybe update your servers, and we'll see you on the next deep dive.